Those are my affiliations. So I'm Peter Teuben. Those are my affiliations at the University of Maryland and associated with ASCL. So the reason why this came up, because we talked about CodeMeta as eventually having an engine that can look for code, discover code. And for example, if you think about what kind of applications in a Fourier transform, FFT, does there exist in different disciplines? That might be hard because you need to see a level deeper, so to say, what a code can do. If I tell you there is this code called Nemo, which I will give an example of, that does stellar dynamics on the top level, there is not a whole lot that you get from that, what it can do, and it might be helpful. So that's how the question came about. I think I don't need to say much about this other than remind you that in ASCL, we have an automatic template generator. The 10.10.051 is the example of Nemo. So when you just put the word Nemo in there, it will resolve itself to 10.10.051. And then if you add CodeMeta or citation CFF, you get the template of that one. I don't think we have a mechanism to grab an existing one, because I think I updated my personal one. Examples of code metadata on the top level, we've all seen those probably. I'm not sure how complete this is. There's probably one or two more. So what do we do when we want to do one level deeper? First of all, it would be optional, and not everybody can or will want to do that. And in a sense, it's a simplified API into the package, and the package could be a package of tasks. It could be a library of classes and functions that does something, and then you have to link or use it. But it can aid in the code discovery. On its simplest level, I would say you can have a one-line description of the tasks if you have a package, or the classes of the functions if it's a library, for example. But that approach does not work very well for a GUI-facing code or dynamic APIs. I know examples of code in our field where the APIs are more or less dynamic. And if you look at Python code, you have the whole mess of the args and the quarks. How are you going to cover those if you wanted to do it this way? So there are some practical issues with this that make it very difficult, make it more difficult to go one level deeper. Often code has an automatic way. Many people now write documentation and they have tools to automatically extract certain types of information of the API. So there are ways already to generate that. And if you don't have it, maybe you should. So again, in the Nemo package that I'll use as an example here, we do have this, and I have a way to automatically generate this. So the example in Nemo, all you need to know at this stage that Nemo is a package that does stellar dynamics and body simulation, orbits and galaxies, that sort of thing. It has about 400 tasks, if you wish. There is a library, and you make Unix programs, and you put them together in shell scripts, and you pipe information between them, that sort of thing. Every task has a Unix man page. We, of course, are suffering from the problem the man page often is out of date because people change their program but don't bother to update the man page. So we actually have a Python tool to link the two of them. But the tasks are all self-describing. You can do -- help, or help equals H, or various options, and they will describe the task. And one of these options is the usage line. For example, snapplot is a program that makes a face plot of a snapshot, an embodied snapshot. And that is coded in the actual source code. And so the self-describing part helps you once you have a task list of all these 400 tasks, you can automatically create that list. Snapplot does this particular thing. CCD FFT does this particular thing. I have a link here that gives an example of that script in the environment of Nemo. And I think, so this is the actual list that we have. And that would be the kind of information that one level deeper in CodeMeta would be available to users to search through. So I discovered when I did this task list is just over 200, but to my surprise, I had 400 tasks in my bin, so I clearly have an issue here where I have lots of them missing, but that's my problem. Okay, I don't think so here's the example of my current CodeMeta JSON. The beginning and ending of that file, and the highlighted yellow is the example that I came up with, where I made a list. The task list is a list of a dictionary, and I decided on name and description from the previous page that you saw. But you can do that on any level. You could even think, if you're crazy enough, to go one level deeper and also give the keyword names, the API names for this snapplot program. But that didn't make much sense to me in my case. So I decided that this is probably one level deeper, is a useful thing, for optional useful thing for CodeMeta.json. And I think that's it. All right. Did that work?
Awesome. Any questions for Peter?
I'm wondering, Peter, have you talked to any of the CodeMeta people to see?
Oh, actually, no. Probably somebody should introduce me to that.
Okay, because to put this in context, this came up when we had our meeting in Maryland a long time ago, before pre-COVID. Yeah.
And I immediately realized, oh, wait a minute, I already have all the infrastructure, and I was able to put that together in 15 minutes. But we've never gone beyond that, so I should.
Hervé has a question.
Yes, that's a very interesting suggestion. As in my own experience, which is more bioinformatics software, it's quite a common pattern that some package will include many different tools. And in that case, automating this way, generating the list of tools included in a package, it could be extremely useful. So my question is, could it be added to CodeMeta in a way as an extension of CodeMeta? Mm-hmm. My thinking is CodeMeta is linked data. So is there a way to, in a way, interpolate it with different context so that you can add, new metadata which are not included in CodeMeta, and still generate valid CodeMeta files this way?
Yeah, I don't know how to answer that other than does it really need an extension or a plugin for that, or does it automatically generally skip JSON items that it just doesn't know about? It depends on the engine that's looking into things.
I would assume that by default, if you have a new key, for instance, which is named task list, and this key is not defined by the context, sorry, I'm losing my voice. The generated file would be detected as invalid by at least some parsers. I would say the Google one would probably not like that. Other than that, I'm not, I'm not an expert in that domain, but yeah, that's it.
Yeah, that makes sense.
What would this do to the size of CodeMeta files? If you've got tasks.
Yeah.
And we have, I mean, just an ASCL, if everybody did that, they won't, we already know that, but if everybody did that, how much larger would that make our contribution to the searchable, CodeMeta data set that we provide to our collective search engine?
Yeah, I'm just looking at mine. The CodeMeta is about 2K and my task list is about 10K, but there's going to be the overhead of all the crap here. So multiply that by 2.
Right.
So that would make the CodeMeta from 2K to 20K.
Right. So I wonder if then we want to look at a 2-tier search. I don't know if that really makes sense.
Yeah, I thought about that too a little bit, in the sense that when you have your registry of all the registries, and you would want to search across domains, that means that there would be a GUI button that says go one level deeper.
Okay.
But I cannot imagine that. When I looked at the list, ours has 2,300 ASCL, but I saw some that have 1 million or whatever it is.
Yeah.
I cannot imagine that those million will go one level deeper. Right? That's a lot of intimate work with your code that has to be done before this can take place.
This is true. One point I'd like to make is, in my experience, sometimes people will search for a package using not the name of the package, but the name of what you call the task here, which might be sometimes an executable binary or something like that. So that makes it, in my opinion, it's positive for discovery purpose.
Yeah, more information is always better. Well, it's usually better for discovery. Depends on how good the information is, but yeah.
I guess it really depends on the user, but in my experience, some users will only know the name of the task itself.
Yeah, we found that true when we were talking about a large package called Starlink, whether we wanted to register Starlink itself or the packages underneath it, or both, because some people were using Starlink packages without realizing that they were using Starlink. So we ended up registering both, but it was a very long and sometimes contentious conversation that I had to be persuaded. I had to be persuaded to the merit of registering both Starlink itself and then the 40 or 50 or 70 packages underneath it, because people are using those packages independently and they want to cite them independently. They don't want to cite Starlink because they don't even realize that it's a Starlink package. So, yeah.
I have that same thing with Nemo. There are certain programs in Nemo that are very sophisticated and they could stand on their own, but I don't bother with it. It's just too much work.
Yeah. Well, I'm happy.
I think we've got a excellent set of discussions for future meetings, and this idea of kind of what level of granularity we want to describe our software is really fascinating. So thank you so much, Peter, for the talk. I'm going to stop the recording.